Welcome back, everyone. Ready for another deep dive.
Absolutely. Always ready to explore.
Today, we're going back in time, back to the 18th century.
Oh, the good period. Lots of powdered wigs and revolutions brewing.
You got it. We're going to delve into the world of Antoine Lavoisier, the father of modern chemistry.
Ah, Lavoisier, a giant in the field.
Right. And we're going beyond the basic textbook stuff, really trying to dig into how he revolutionized chemistry. We've got some fascinating excerpts from a Spanish language biography to guide us. So get ready for some serious deep diving.
Sounds intriguing. I'm always up for a challenge.
All right, so where do we begin? Well, Lavoisier's journey to becoming a scientific icon wasn't exactly straightforward.
Oh, this I know. He didn't start out in the lab, did he?
Nope, not at all. Picture this. 1743 France. Born into a family of lawyers.
So destined for a life of legal battles, not chemical ones.
You'd think so, right? He even got a law degree.
Ah,
But clearly, his heart, his mind were yearning for something more.
there had to be something else bubbling under the surface. You don't just become the father of modern chemistry by accident.
Exactly. And that's where his path takes an interesting turn. While studying law, he found himself drawn to the halls of College Mazarin.
College Mazarin, wasn't that a hub for scientific exploration in the 18th century?
It was. They had it all: astronomy, botany, geology. But chemistry was the one that truly captivated him. I mean, imagine being exposed to all those disciplines. He must have been like a buffet of scientific knowledge.
Oh, absolutely. A true feast for a curious mind. But we have to remember, this was the 18th century. Chemistry back then wasn't quite the structured science we know today.
You're right. It was still very much entangled with alchemy.
Alchemy, the pursuit of turning lead into gold, the elixir of life.
That's the one. It's almost hard to believe, but in Lavoisier's time, people still clung to these alchemical beliefs.
They did. Many still held on to the ancient Greek notion of four elements: fire, earth, air, and water.
And into this world steps Lavoisier, with his legal background, his sharp analytical mind. He's ready to challenge these long-held assumptions. And one of his early experiments, the Pelican experiment, really showcases this.
The Pelican experiment? That rings a bell, but refresh my memory. What did Lavoisier do?
Picture this. Lavoisier boils water for 103 days straight.
He boiled water for over 100 days. What was he trying to prove?
He was directly tackling this ancient idea that water, when boiled for long enough, could be transmuted into earth.
Oh, right. That was a prevailing theory for centuries. So did he end up with a pot full of dirt?
Well, he did find sediment, but here's the thing. The weight of the water remained the same. He used a special sealed container, a pelican, that allowed the evaporated water to cycle back down. His conclusion: the sediment wasn't the water transforming, it came from the container itself.
Ah, he was already thinking like a true scientist, isolating variables, looking for the real cause and effect. A far cry from the alchemist's approach.
It was a pivotal moment, really. He was challenging those deeply rooted alchemical beliefs and laying the groundwork for a more rigorous, evidence-based approach to chemistry.
Exactly. And this emphasis on meticulous measurement, on collecting and analyzing data, became a cornerstone of his work.
And that's where the story gets really interesting, because this focus on measurement led him to take on one of the biggest scientific challenges of the time.
Let me guess, this is where we get to the showdown with phlogiston.
You got it, the phlogiston showdown. It's a classic story of scientific revelation. But first, for those of us who weren't around in the 1700s, can you give us a quick rundown of what phlogiston was all about?
Okay, so imagine phlogiston as the essence of fire, almost like a substance released during burning. This is why things burned, and why they eventually stopped in an enclosed space. The air became saturated with phlogiston, you see.
So phlogiston was like the fuel of fire, and once it was gone, the fire went out. Sounds plausible for the time, right?
It was a pretty neat theory for its time. It explained a lot. But Lavoisier, he wasn't fully convinced.
Of course not. He's Lavoisier, always questioning, always testing. So what did he do?
He starts experimenting with things like phosphorus and sulfur. And as always, he's meticulously measuring their weight before and after they burn.
And I'm guessing the results weren't quite what the phlogiston theory predicted.
You're catching on quickly. Instead of losing weight as phlogiston was supposedly released, they gained weight. It completely contradicted the prevailing theory.
That must have caused quite a stir in the scientific community. So what was causing this weight gain? What was Lavoisier's explanation?
He suspected that something was being absorbed from the air during combustion, not released. But he knew he needed a truly dramatic demonstration to really shake things up, to make people pay attention.
Okay, now you've got me on the edge of my seat. What did he do?
He decided to burn a diamond.
He burned a diamond.
Yeah,
That's bold, to say the least. Diamonds were precious even back then, right?
Absolutely. But Lavoisier, he wasn't afraid to think outside the box. He got his hands on some giant lenses, basically a super-powered magnifying glass, focused the sunlight, and, well, he burned the diamond.
He actually burned a diamond. What did that prove?
It showed that diamonds weren't some indestructible magical substance, but something that could react with air. It further fueled his idea that combustion involved a combination with something in the air, not just the release of phlogiston.
So this is where oxygen enters the scene.
You got it. Lavoisier's meticulous work, his questioning mind, his daring experiments, they were all paving the way for a major scientific breakthrough, the discovery of a brand new element. It wasn't just about burning diamonds, though. I mean, it was impressive, but there's a bigger picture here.
Right, he was onto something much larger.
Exactly. He started to realize just how important this something in the air really was, not just for burning things, but for life itself.
Okay, so this is where we finally get to oxygen.
Precisely. The element we now know as oxygen.
Now, I have to admit, oxygen isn't exactly the most poetic name. I mean, it gets the job done. But is there a story behind why he called it that?
Well, like a good scientist, he was looking for patterns. He actually thought this gas, oxygen, was a fundamental piece of all acids.
So the secret ingredient to making acids. Interesting.
Yeah, he even formed the name oxygen from Greek words, basically meaning acid generator.
Ah, that makes sense. But I'm guessing his theory about oxygen and acids didn't exactly hold up over time.
Well, no, not quite. Science is all about refining our understanding, right? It turns out oxygen isn't the key element in all acids.
But the name stuck anyway, even though the theory behind it wasn't totally accurate.
It happens all the time in science. Sometimes names, they stick around, even if the initial understanding evolves. It's a reminder that science is always a work in progress.
Definitely. But, you know, it's important to remember that Lavoisier wasn't alone in this race to understand oxygen. There were others like Joseph Priestley and Carl Wilhelm Scheele also working on this around the same time.
Oh, absolutely. Science is rarely a solo endeavor. It's a community effort, even if sometimes there's a bit of friendly competition.
Right, like who gets the credit for a discovery it can be tricky. Especially back then, communication wasn't as instant as it is now. So what about these other guys? Priestley and Scheele, what were they up to?
Well, Priestley, he was an English clergyman, a scientist, and quite the character. He actually isolated oxygen by heating mercuric oxide, I believe. And Scheele, a Swedish chemist, might have even isolated it earlier, but his work wasn't published as quickly.
So a real race to understand this new element, and lots of brilliant minds contributing to the puzzle.
Exactly. It's a testament to the collaborative nature of science, even when there's individual ambition driving things forward. It all adds to our collective knowledge in the end.
Now, speaking of collaboration, we can't forget Lavoisier's wife, Marie-Anne Pose Lavoisier. She was a key player in his scientific journey, not just a supportive spouse, but a true partner in his work.
Marie-Anne, oh, she was a force to be reckoned with. I mean, she was translating scientific texts, she was illustrating Lavoisier's books, and even conducting experiments with him.
A true power couple of science.
Yeah.
I bet those late-night lab sessions were something else.
They must have been. It really highlights how important collaboration and diverse perspectives are to scientific advancement. You know, bouncing ideas off each other, challenging each other's thinking.
Speaking of challenges, we can't forget Lavoisier's work on creating a clear and systematic language for chemistry. It was almost like he was cleaning up a big mess. I mean, before him, it must have been hard for chemists to even communicate with each other effectively.
Oh, absolutely. Before Lavoisier, chemical language was a bit of a hodgepodge. Imagine a world where every chemist has their own system for naming elements and compounds. It would be chaos.
It sounds like trying to have a conversation in a room full of people speaking different languages.
Exactly. Lavoisier realized that the old alchemical terms were just too vague and often downright misleading. They were holding chemistry back. It was like trying to build a skyscraper on a foundation of sand.
So he decided to just scrap the old system and create a new one?
Well, not entirely on his own. He got together with some other big names in chemistry, people like Claude Louis Berthollet and Louis Bernard Gaetan de Morveau.
And they set about creating a new language. one that reflected the emerging understanding of what substances were truly made of.
Exactly. So instead of relying on those vague, almost mystical names like spirit of wine or oil of vitriol, we started to get terms like ethanol and sulfuric acid, names that actually told you something about the elements involved.
It was like everyone in the field suddenly started speaking the same language. It must have been a huge shift.
A total game changer. This new language allowed for greater clarity, accuracy, and consistency. It unified the field of chemistry and set the stage for the modern chemical nomenclature we use today.
And you know what? That's a theme we see throughout Lavoisier's work. He wasn't just making discoveries. He was bringing order and clarity to the field.
It's true, and his impact went beyond just combustion and nomenclature. He applied this rigorous, methodical approach to understanding other areas of chemistry, like the composition of water.
Ah, yes. His work on water, that was another big blow to that old four elements theory, wasn't it?
It was. I mean, for centuries, people thought water was a fundamental, indivisible element. But Lavoisier, he saw things differently. Building on the work of Henry Cavendish, he suspected water was actually a compound, a combination of hydrogen and oxygen.
But how did he prove that? I mean, this is the 18th century. They didn't exactly have the fancy analytical tools we have today.
No, they didn't. But Lavoisier was incredibly resourceful. He and Laplace, they came up with these ingenious experiments to actually decompose water into its component gases.
So they were able to separate water back into hydrogen and oxygen.
Precisely. And then they went a step further and recombined those gases to produce water again. It was like taking a clock apart and then putting it back together to prove that you understood how it worked.
Wow, so they basically took water apart and put it back together.
Yeah,
That's a pretty definitive way to show that water wasn't a simple element.
it really was. And his explorations didn't stop there. Lavoisier, he was a curious mind. He started delving into the process of respiration.
Respiration,
Hmm.
like breathing.
Exactly. He realized that respiration at its core was actually a form of slow combustion. He even used a guinea pig to measure the heat and carbon dioxide output during respiration, linking the process to chemical reactions.
So he was starting to connect chemistry to biology, almost like laying the foundation for what we now call biochemistry.
Exactly. Lavoisier's curiosity truly knew no bounds. And his work, his rigorous methodology, his attention to detail, it had a ripple effect across various scientific fields.
He was truly a polymath, pushing the boundaries of knowledge in multiple areas. But it wasn't all lab coats and experiments, right? Didn't Lavoisier also play a major role in public service? Wasn't he involved in the government and all sorts of other things?
Oh, absolutely. He was a scientist-statesman. He served in various government positions, using his knowledge for the betterment of French society. It's actually quite fascinating.
Yeah, and I remember reading about his work on gunpowder production. Didn't he help significantly improve the quality and quantity of gunpowder being produced in France?
That's right. He served on the Gunpowder Commission, and I believe it was in 1775. He really got things moving. He implemented all sorts of advancements in the production process, and it made a huge difference. Led to a surplus that benefited France both financially and militarily. Some even say his work on gunpowder played a role in Napoleon's later victories.
Wow, so a chemist working in a lab ends up influencing the course of history. It really goes to show how science is connected to everything.
It does, and his dedication to public service didn't stop there. He even authored a report on the terrible conditions in Parisian prisons, sparked reforms to improve sanitation, healthcare, the treatment of prisoners. He was really trying to use his knowledge and influence to make a difference.
Lavoisier, what a remarkable figure. Revolutionizing chemistry, improving gunpowder, advocating for prison reform, all while navigating the complexities of 18th century France.
It's an incredible story. But sadly, as we know, this story takes a tragic turn. You see, despite all his achievements, Lavoisier's life was cut short during a very turbulent time in France, the French Revolution.
The French Revolution. It's one of those periods in history that just captures the imagination.
Oh, absolutely. A time of immense upheaval, a real turning point.
And for Lavoisier, it ultimately proved to be a fatal one. I mean, it's hard to believe that a scientist of his stature, someone who contributed so much to France, could become a victim of the very revolution he lived through.
It's a tragic irony, isn't it? And, despite all his achievements, it was Lavoisier's connection to the Ferme Générale, the tax collecting agency, that really sealed his fate.
The Ferme Générale. I vaguely remember that from history class. Wasn't it a pretty controversial organization?
It was. I mean, it was crucial for generating revenue for the state, but it was deeply unpopular among the people, seen as a symbol of inequality and oppression, you see. And when the revolution began, while anyone associated with it became a target.
So even though Lavoisier was working to improve systems to make things better, his association with the Fermi General ultimately led to his downfall.
Sadly, yes. When the revolution reached its peak, the reign of terror, public sentiment had turned against anyone seen as part of the old guard, the old system.
It's heartbreaking. All his work, his discoveries, his efforts to improve things, all overshadowed by his connection to the Fermi General. Did he even have a chance to defend himself?
Oh, he did try. He presented his scientific contributions, his record of public service, as evidence of his loyalty to France. But the Revolutionary Tribunal, they were unmoved.
The political climate had changed so drastically. It was a dangerous time to be associated with the old regime, regardless of your accomplishments.
It was. And the result, as we know, was a devastating loss for the world of science. On May 8, 1794, Lavoisier was executed by guillotine. He was only 50 years old.
50 years old. It's hard to fathom the immense loss, the potential discoveries, the advancements that were cut short.
It's a stark reminder of the fragility of life, isn't it? Even for those who achieve greatness.
Absolutely. But despite this tragic end, Lavoisier's legacy lives on, doesn't it?
It does. His impact on chemistry, on science as a whole, is undeniable. I mean, think about it. His meticulous approach to experimentation, his insistence on clear and concise language, his groundbreaking discoveries, all of these things shape the way we do science today.
He's still considered the father of modern chemistry for a reason. His work on combustion, on oxygen, on the composition of water, these were all monumental achievements.
He transformed chemistry from a field shrouded in mystery to a true, quantifiable science.
And his story, well, it's not just about scientific breakthroughs. It's a reminder of the complex interplay between science, society, and politics.
It is. I mean, think about it. Lavoisier was ultimately condemned for his connection to the Fermi General, not for his scientific work.
Right. It makes you wonder, if his contributions to science were so evident, why wasn't he spared? Can science and politics ever truly be separated? It's a question worth pondering, isn't it?
It is. Lavoisier's story serves as a powerful reminder that even in the pursuit of knowledge and progress, we are inevitably intertwined with the social and political forces of our time. It's a reminder to be mindful of the context in which science operates, to use our knowledge responsibly, and to always strive to make a positive impact on the world.
Well said. And on that note, I think we've reached the end of our deep dive into the extraordinary life and legacy of Antoine Lavoisier, the father of modern chemistry. It's been quite a journey.
It has. Fascinating and thought-provoking.
Thanks for joining us today, everyone. Until next time.